welcome to our channel. Today we discuss a very interesting problem in the linked list, merge nodes in between zeros. So you are given the head of the linked list which contains a series of integers separated by zeros. The beginning and end of the linked list will have the node.value equal to 0. I think this is the point which we need to observe. So the problem statement says the beginning and end of the linked list will have the value equal to 0. For every two consecutive zeros, merge all the nodes lying between those zeros. So the modified list should not contain zeros. So these are the points we need to understand when we're reading the problem statement. So the start and end are zeros and the final output should not contain zeros. So the return the head of the modified linked list. So for this example, as you can see, between these 0 and this one 3 comma 1, so 3 plus 1 4, and between these zeros 4 plus 5 plus 2 equal to 11. So the final output should be 4 comma 11. Let's dive into the problem and understand more so that we can solve this problem in C# language. Hey everyone, so let's understand the problem a little more. So let's take an example of a linked list 6 and again 0 3 5 and 0. So maybe this is 8 and this is 9. So as you can see in this example, so the starting and the ending are ends with 0 and in between there are non-zero values. So in this, these are the non-zero values and these are the non-zero values, and again 8 9 are the non-zero values. So the final node should have 4 9 15 and 17. So this should be the final node we should return as a output, right? So let's dive into more into the solution and let's understand more with the final. Okay, let's go and write the solution in C sharp, and I will walk through the final code, how it looks like and what is the reason for each statement here. So as you can see, this is the public class list node with the value and the list node next, which will refers to the next node, point to the next node. So whenever we're trying to solve linked list problem, the practices we will try to do is creating a dummy node, right? Create a dummy node to serve as the head node of the modified linked list. So in the previous example, the four, let's say 15 and 17, so that is a modified linked list. So this dummy node will be kind of the head node for the final output. So let's say dummy node next will be our head, right? As we have to traverse through the linked list from 0 to 0 and sum the values, so we need to have the previous equal to dummy and list node dot equal current equal to head, right? So we need to traverse the linked list, right? So the standard condition will be when till the current node is not equal to null. So what is our, so when we want to start the loop to get the sum of the node values, so whenever we hit the point where, if the point where the current dot value equal to 0, right? Because that's where we want to start our loop to get the sum of values. So let's say we are taking the current dot next as the next node, right? And while next, as long as next is not equal to null, and next dot value, here it is other way, right? As long as the value is not equal to 0, that is where I want to sum equal to value and current dot next. So it should be kind of the standard practice if you're familiar with all these linked list problems. So we will traverse to the next node, and next will be the current dot next, right? And what if the current dot value equal to 0? If the current dot value equal to 0, then previous dot next equal to current dot next. We will update our previous value, right? And so this is our while loop. So out of that, the previous will be become current, and current will become current dot next. And the final will be, as I said, the dummy node will be the add. So the dummy node next will be our final result, right? So it is done. Okay, let's talk about the time and space complexity of this solution, right? So that is very important, very important for any solution. So we solve the problem. Now we need to talk about the time and space complexity. So the method travels the linked list exactly once. So we will traverse from 0 to 0, get all the non-zero values and sum of them. So it is just kind of one traverse through the linked list. So the travels time will be order of n, where n is the number of nodes in the linked list. The space complexity will be order of n, since the space for the new list depends on directly on the input size, but it is not duplicated or multiplied. The space used by the new list will be effectively order of n. So to summarize, that time and space complexity is order of n, and the space complexity also order of n. So if you're interested to know more about these kind of problems, these are the kind of the similar problems which you can solve. Like, let's say reverse nodes in a k group, remove duplicates from the sorted list, partition list, merge two sorted list, intersection of two linked list, right? So these are the similar problems which you can solve to understand more about a linked list and understand their reversing the nodes and understand the different kinds of problems. So that's all from this video. So we will talk again into the different problem again in future videos. Thank you.